Okay, we only had one more topic to talk about, and it's really just a calculation from the end of the thermodynamic thermochemistry notes. So we were talking about this curve, and the last homework assignment, we were talking about how this section here, and this section here, and this section here is about the molecules speeding up, and that this section here and this section here is about the molecules breaking apart. There are intermolecular forces uh, disconnecting from each other. And so let's do a calculation. We'll do water, and we'll do the calculation for water as going from this 25 degrees Celsius all the way up to, we'll say, 400 degrees Celsius. So if I have a block of ice and it's at negative 25 degrees Celsius and I take it all the way up to 400 degrees Celsius, how much energy is that going to consume? And let's say we're going to do, make it easy, we'll do 250 grams. So not a very big container, but regardless, 250 grams. All right, so we're actually going to need to do 5 separate calculations, and then we will add all of those calculations up. So let's go ahead and start off with, we're gonna heat the water, so make the ice jiggle faster. And so we're going to go from negative 25 up to 0, because we know that's where the water is going to be melting. And so that means we're going to need to use the specific heat equation, Q equals Cm delta T. All right, so we want to know what our Q is. And our C is going to be, since it's ice, it's 0.5 calories per gram degrees C. And then our mass, we said 250 grams. And my temperature change is 25 degrees Celsius. So why is it 25 degrees Celsius? Because the ending value is 0, and then we subtract off negative 25 degrees, which changes the sign and makes it a positive 25 degrees Celsius. So we end up with a calorie unit. That's all that we have left. And so that's going to be 0.5 times 250 times 25. So this is 3,125 calories. Okay, so that's how much energy it takes to do this part right here. All right, so let's do the next part. Got another Q. The next part, we're going to be using Q equals MH. And so the H is the heat of fusion. And so that's given right here in this problem for water. And so we just need to know the mass and how many calories it takes per gram, in this case, to melt ice to turn it into liquid water. So we'll just start off with our 250 grams, and then it's 80 calories per gram. And so 250 times, okay, so then 250 times 80 is 20,000. So 20,000 calories to take the water from ice at 0 degrees Celsius up to liquid water at 0 degrees Celsius. Okay, so what we're doing there is we're breaking the intermolecular forces of the ice, of the water that is stuck in the ice crystalline structure. I'm breaking apart that crystalline structure until the water, all the water molecules are able to be liquid and moving around. And so that's going to take 20,000 calories. All right, my next thing is I'm going to go here, and I'm going to raise the temperature of the water from 0 up to 100. So that means I got to use my my equation that's got a change in temperature in it. So Q is equal to, in this case, 1 calorie per gram degrees C, because we're talking about liquid water, and then 250 grams. And then this is 100 degrees Celsius, because we're going from 0 up to 100. The degrees C and the grams cancel out, and we've got calories here. So, well, that should be easy. 2500. So 25,000 calories to get the water to go from 0 all the way up to boiling. All right. And so then next thing that's happening is we're going to boil the water. Okay. So that's going to be 250 grams. and we're going to use the heat of vaporization. And in this case, the heat of vaporization is 540 calories per gram. So you can see that the heat of vaporization for boiling is much higher than the heat of vaporization for melting. And so that's going to give us 2,500 or 250 times 450, 540, sorry, 135,000 calories. So that's super energy intensive. So it's almost 7 times harder to boil water than to melt ice. That's what we're looking at with the 450 compared to the 80 calories per gram. And then the last piece here, we are going to do this. We're going to raise the temperature of the now gaseous water from 100 all the way up to 400. So we're going to have to use the equation that's got the change in temperature in again. So Q equals, and then in this case, it's the same situation, 0.5 calories, because we're talking about water as a gas, and its specific heat is half, and then still 250 grams. And now we're going to go 300 degrees Celsius, 400 minus the 100 that we started at. And so then 300 times 250 times 0.5. So that's 37,500 calories. So you can see the most most energy intensive portion of this is the boiling. And then right behind that, we've got raising that temperature of water and melting that water. All right, so we're going to add all these guys up. So the 37,500 plus the 135,000 plus the 25,000 plus the 20,000 plus the 3125. And so we're at total 220,625 calories. So probably have 2 sig figs here. So basically 220,000 calories to go from negative 25 degrees Celsius all the way up to 400 degrees Celsius if I'm talking about 250 grams of water. Okay. And that's it for this set of notes. And okay.